All right. So the rest of the week, we'll go over the worksheet today. Tomorrow, quick quiz. By quick quiz, I mean 2 questions. All right, 20 points. Here's what's fair game for tomorrow's quiz. Topics that are fair game for tomorrow's quiz. Inscribing a rectangle under a curve. Can. Whether I restrict the volume or restrict the surface area. Fencing. Not like touche. Let's see, what am I missing? Box. So inscribe a rectangle. Can. Fence. Box. Sounds good to me. 4 topics, 4 possible topics. How did the homework go, do you think? Bad?
Yeah. So confusing.
Okay, well. Hold on a sec. Okay. We need to find some common ground here. Okay. I know it's tempting to come in any class and say, oh my gosh, I don't know what I'm doing. Like there's some like comfort sometimes for students in like commiserating in pain. There is. You know what I'm talking about. Oh, the chem was so tough. I don't know what I'm doing. It's impossible. Right? All right. Now, let's start with what went well. Were there any problems that you're like, you know what? That wasn't that bad. I've seen this before. I can do this now. Number 2? Gavin, it didn't have any E's in it. It should have been cake. All right? Should have been cake for you. Madison. Yes. Next. How was 3?
It was kind of rough. It took a minute.
Okay. 4. Tony's ready for this.
No, not 9.
Tony used to twist.
9 was rough.
Okay. All right.
That's pretty cool.
Tyler.
On 9, how do you find the base for the rectangle? That's what I'm confused about.
So 8 minus x cubed. Like that, right?
Yeah.
And the rectangle has to be drawn inscribed in the closed region bounded by the x-axis, the y-axis, and the graph. So there's only one vertex touching that curve. Here's the curve. The top right vertex is touching the curve. That determines your height. But the left edge, it's not like the other inscribed problem we did where they're both touching the curve. The left edge can't go past that y-axis. So it's just kind of following the rule of this right one. Makes sense? The base of that rectangle would be x, wouldn't it? Height would be 8 minus x cubed. Length times width. All right. Let's check our answers. Now, this is a resource that I found. The work is worked out for us. Here is, now whether you called X or Y, the partitions or the outside edge, doesn't really matter. Just check that you get the right numbers. 50 feet by 125 feet would be the dimensions. What was the constraint for that problem? You're only allowed to use 500 feet of fencing, right? Perimeter. Perimeter would be the constraint. Doesn't it take 1, 2, 3, 4, 5 x's plus 2 y's? 5x plus 2y equals 500, or 5l plus 2w, whatever you call that. You got to choose which variable you plugged it in for, or which one you solve for, I should say. You're trying to maximize area, so we have length times width. Plug that into here. Derivative, so equals 0. Are we getting more comfortable with the calculator doing that? Where's your stuff, Tyler?
Right here. My paper's right here. I'll be honest, my calculator hasn't been charged this entire time. For the past 4 days.
Spidey senses aren't tingling right now?
Nah.
For
Right
calculus? All right, what's the next one? 3? What questions on that one? 3? There's no top. So you have, no, I don't have it in front of me. Ooh, someone put it there. An open rectangular box with a square base. Okay, an open rectangular box with a square base. That was part of a key part of the problem there. Is that the base is square and that there's no top on it, so you didn't want to include that in the surface area. So now you have to come up with what is the surface that I'm calculating. Well, I've got an XY here, I've got an XY here, I've got an XY here, and on the back I've got an XY, so I have 4 XYs. And I don't have 2x squareds, I only have 1x squared since there's only a bottom. That is the surface you have to calculate. Does that make sense to you? And what's the restriction? 48. What did they say? Square? Something like that. You say feet squared? 48 square feet of material? I think y is easier to solve for. You didn't have to write it like they did. 12 over x minus x over 4. You could have left it 48 minus x squared over 4x. That's fine. Leave that in parentheses. That's the constraint. We're trying to maximize the volume. Does everybody agree the volume is going to be x squared, which is the area of the base, times the height y? And since we solve for y, we're plugging that in for y. And from there, I hope you guys are okay plugging it in the calculator and testing. Let's refresh our memories. What checkpoints are we looking for? And I addressed the first derivative test checkpoints. So let me start off here. The checkpoints you should be considering are, what's your objective? Constraints. Okay. Equation to be optimized. Now, what I mean by that is it's either going to be a min or a max. So I put it in the steps. I put objective equation with the constraints plugged in. That's what I'm talking about. Do you have to number these? No, but I do need to see these as your checkpoints. And then 4 is the test of the derivative. I need to see the derivative. I need to see the critical points. I need to see the extrema. And then a justify. Derivative. From here, it's the calculator. Derivative. Critical points. There may be more critical points than actual extrema that you're going to list, because you're only going to list the extrema that apply to the problem. They're saying maximize the volume. You're going to show the one that at this point, you're going to give me all the critical points. At this point, you're going to give me the one that maximized the volume. Then you're going to say there is a maximum volume when x equals blank, whatever, because v prime changed from positive to negative.
What is that x squared plus 4xy equals 48?
That's the surface area. X times y is this right surface. X times y is this front surface, back surface, or side surface, and back surface. There's 4 of those. And then the bottom was x squared. Other questions on the process? So the dimensions for this one were 4 by 4 by 2. 4 by 4 by 2. Should be what? 32 cubic feet? Gavin, are you feeling better?
Sure.
Gavin, this is surprising me. I'm concerned, Gavin. Are you getting better?
Yeah.
He's lying to me. Casey, how are you feeling about this stuff? We need like a counseling couch in here, just like a comfortable couch. It's like, Jackson, talk to me about your feelings. How are you feeling about this? I'm gonna say that for AP Lit. Just kidding. Oh. I should have recorded this. Matt, we don't talk about feelings, do we? It's okay. We'll talk about how we feel. Lizzie, how are we feeling about this? Better some iced coffee?
Yeah.
How can I help you? Mason, how can I help you?
Are you gonna post this? So
I can post that, yeah. I didn't want to post it last night. I will sometimes post the key with the assignment because you guys can check, but this is too tempting. Honestly, you know what I'm talking about. This is full turtle mode. Okay. We haven't talked about turtles in here? What does a turtle do when it gets on its back on its shell? So sad. Isn't it the saddest thing? Get on their back, they're on their shell. Can they get themselves turned over? No, they just sit there and sometimes you guys look like turtles on your backs. I don't want to do it. I just want to just someone flip me over. It's sad. So I want you guys to try to figure these out. All right, just try to figure them out. Did anyone get all of them right? Anybody get? There were 4 problems right there.
Yeah.
3/4 of them right. Half. A fourth. Own it. It's good. It's all right. 0. It's okay. Life goes on. Don't be a turtle. All right. Joking aside, if I put this key out there, you know what would happen. A lot of people would just be like, okay, problem, okay, key, and just hoping that something sinks in. You have to try these and struggle with them. Okay? You have to. The frustrating thing is most of the process is not calculus. This is not new. All right, you did stuff like this last year, and it was still tough. All right, but you have to try to piece it together. Okay. All right. What was the next one? 7. All right, I'm on slide 6. All right, number 7. That wasn't 7, was it? 4. A container in the shape of a right circular cylinder. Do you know what we talked about a right circular cylinder, didn't we? Okay, good. With no top. No top. Has a surface area of 3 pi square feet. Surface area, 3 pi. Okay. What height and radius will maximize the volume? Maximize the volume. So my objective, pi r squared h is the volume of a cylinder. Does that get affected by no top? Does the volume get affected by no top? No. That's the surface area. Yes. So the surface area equation that we're going to be dealing with, normally we'd have 2 pi r squared, top and bottom, plus 2 pi rh. But Tyler, this time we only have plus 2 pi rh. Pi r squared plus 2 pi rh. And we're told that the surface area is 3 pi. We just restricted the problem. What variable is easier to solve for in that problem, r or h? H. We subtract pi r squared, we divide by 2 pi r. Subtract pi r squared, divide by 2 pi r. Seven. Oh, you guys tricked me. Next time. All right. They called it x and y. It's all right. Again, I don't like how they break up the fraction. I think it's easier to plug in if you just. Oh, they're divided by that. Okay. I leave it as one fraction. There's some cancellations that can happen. If we would have done that, if we would have had pi r squared times 3, it was 3 pi minus pi r squared over 2 pi r, I believe, equals h. This is where you can cancel the pi's, cancel one of the r's, and you're going to have, you have a choice. You can write r times parentheses 3 pi minus pi r squared over 2. Or you could distribute that through and say 3 pi r minus pi r cubed. Okay, it's up to you. Doesn't matter. That goes into the volume because we're trying to maximize volume. That goes into the volume. Is it getting that equation that is tripping most of us up? I am guessing. It's getting the, how will I word this? Changed picture. We did a can yesterday. This is a changed picture. There's no top on this one. Were you able to adapt and come up with a different formula, or was that the hard part? Tyler?
I have a completely different formula for h. Not the right answer.
What'd you get?
H is equal to 3 minus r squared over 2r. Because whenever I solved for, I think it was h.
You have that same answer. Up on the 3 first lines, divide both sides by 2x, and you just use r for x. It's the same equation.
Yeah. You said 3 minus r squared over 2r?
Yeah.
Yeah. Because if you do common denominators, that's an r. That's an r multiplied by r. 3 minus r squared over 2r. Yep, you're good. All right. What do you want to do? As a teacher, this is a tough spot to be in because I've explained the process, but what's the challenging part about these problems? Everyone is different. To be honest, isn't it? I mean, that's when things are tough. Because what do we do as students? We get in the habit of repetition. Oh, point slope form, algebra 1. Probably got 30 questions of homework on point slope form, right? Slope intercept form. You just do 30 of them. Didn't even have to think about it, right? Pre-calc got kind of tough because, trig identities, trig proofs, everyone's a little different. Calc, tough. Every problem's a little different, right? That's where this can get tedious. What was the next one? After 4, it was 90. So here's the curve. Tyler and I were kind of talking about this one. Here's the curve. And the rectangle has to stay in the first quadrant. So this left edge has to stay on the y-axis, the bottom. I guess the width of the rectangle has to be on the x-axis. So the width, do you agree it's x? Are you guys okay with that now? X is if it goes from the origin out, it's x. If it's symmetric and it goes both ways, it might be 2x, right? Adam?
How do you know that it only is in the first quadrant?
The question said rectangle of the largest area which can be inscribed in the closed region. So the curve was here. Closed region bounded by the x-axis, the y-axis, and the curve 8 minus x cubed. So this rectangle has to stay in there. Right? So the width is x. The height is y. That's fine if you do that first. I don't mind. If you put the height as y, and then you say what y is equal to in this context, y is equal to 8 minus x cubed. Because what might happen is you may go to do the problem tomorrow, if it's on there, and do x times y. And you're like, oh, geez. I have an x and a y. Y as a function of x is x times 8 minus x cubed. Get this one, Kylie? Awesome. Critical points. I mean, you could do this one by hand. You could distribute the x through, take the derivative, set equal to 0. But we got a calculator. Cube root of 2 is kind of messy. Test it, and you'll see the derivative changes from positive to negative, yielding a max. And cube root of 2 times 6. 6 must have been the height. That would have been your, if you had it as a decimal, that's fine. You had what's the cube root of 2 times 6? Read that, Wayne.
Like the final decimal answer is.
Did you type that in?
Yes, it's 7.56.
Sounds right to me. All right, what questions do you have on that one? Was that the last one? I have not done this, so you're going to see exactly what I would do if I were you. I would figure out, like, if I wanted more practice problems, I would do calculus, optimization, worksheet, maybe even with answers. You get dangerous. I'm clicking on links that I have not checked. Yeah, looks legit. So then I would search for questions like we've done, right? Gardner wants to make a rectangular enclosure using a wall as a side. Express the area in terms of x. Find the value of x that gives the greatest area. All right. Fencing problem sounds familiar. Open box, square base, gives you a surface area. Ooh, this is a classic problem. I did not give you this. There's one in our book like this. I think it's number 20. Jane, I think, is the one rowing. Let me check. If you want to challenge, if this is easy for you, and you want to challenge, let's see if I'm right. Jane is 2 miles offshore in a boat and wishes to reach a coastal village 6 miles down a straight shoreline from the nearest boat. All right. So here's the problem. This is an interesting calculus problem. She's in a boat offshore. Here's the shoreline. We know she can row at a certain rate and walk at a different rate. She has to get to this point on the shoreline. Now, this is the context of a house, but same situation. All right. This is a classic math problem. You're in mud. All right. And actually, if you watch, how many of you watched that Vsauce Berkeisterkern video? Do you remember the mud example? How you have to walk through mud, and obviously, if you get through the mud quickly, you can get out of travel not in mud faster if it's flat, solid ground, and then you can get to the point you want to, or you can go directly through the mud. This is a context of rowing versus walking. All right, where should she land the boat on the shoreline to reach the destination in the least amount of time? Okay, she could row straight there and then walk the whole way. That wouldn't be it wouldn't be a very short path, right? It would be probably the longest path she could take. But depending on the rates, she might be able to get there faster. But maybe she should land somewhere along the shoreline. That's an interesting context of the problem. So if you are bored right now and you want a challenging problem, number 20 in the book. All right? Great problem. I won't be offended if you do that right now. That will not be on there. All right? But it got me thinking. We got answers there. Awesome. Next worksheet. The sum of rectangular piece of land. Yep. An open rectangular box is made by cutting 4 congruent squares. That looks familiar, doesn't it? Looks familiar. An open box with a square base has a volume. What dimensions will minimize the surface area? Sphere. I wouldn't worry about it. It's a little challenging for what we're doing right now. This dude's actually really good. He's pretty well known in the calculus community. Paul. His website's it looks really clunky, but it's actually pretty good. Let's see. When you click on his solutions, you can do like step by step, or you can see them all at once. Are you mocking me? Paul. Good old Paul. There you go. Do you see what I'm saying? I did not plan that. What's my point here? If you want to practice problems similar to what I'm going to give you, use the internet as a resource. I gave you the worksheet. I didn't make extra stuff because I wanted to give you opportunity to practice. And if you're good, you're good. You're ready for tomorrow's short quiz. 2 questions. Just 2 questions. All right. If you're not, I want to provide time today for you to work on problems and ask me questions, because I've told you this. I'll say it again. I don't know what else I can do to get you there. Does that make sense? I've given you the process. I've shown you what's expected. It's kind of on your shoulders at this point. All right? You good? Is that fair? All right. So the rest of the time, I want you to ask me questions. You can practice, go to websites, look at worksheets. Don't be like too quick to settle on one of them. Here's what I would say. You know how the last one we clicked on, it had the key right with it? If you click on a worksheet and there's no key, I would probably skip it. I would look for one that has a key. But you said last night you weren't going to give us the key because we were going to we just look at it. Yeah, I know. That was last night. Okay. Now, if you're like, we have covered everything we need to, it's practice time, and you are on your own to get the solution because everybody in the room might be doing a different worksheet and I can't check them all, you probably want to have the key. All right? But don't use it. Don't be a turtle. Try it on your own. Struggle. Figure it out. Check your answer. Break.